Hi everyone, welcome to my channel. My name is Fikret. This video continues video series dedicated to learning Microsoft Fabric. Here we are exploring different services that are part of Microsoft Fabric. In the past few videos that are dedicated to real-time analytics services in Microsoft Fabric, we have discussed different components like event streams and KQL databases. Microsoft has introduced a lot of enhancement to this service in last few weeks and months. Specifically, I am excited about enhancements that allow you to build low latency pipelines from your databases. So today we'll be discussing these enhancements as well as explore the way to build real-time analytics or real-time intelligence based on your databases. Let's dive into it. Here are the topics that I'm going to cover today. So we'll start with the overview of real-time intelligence, where I will describe landscape of real-time intelligence service. I'll explain the services used for ingestion, transformation, data storage, and data consumption. Next, we'll talk about event streams, which is a core ingestion tool for real-time intelligence. So we'll explore different data sources and destinations, and we'll consider the capabilities of this service. Next, we're going to talk about change data capture, which can be enabled on certain databases. So this is relatively old technology, but we'll be using this feature to build low latency pipelines to Fabric. Next, I'll demo how to enable change data capture, or CDC in short, for Azure SQL DB. And then we will build event stream pipeline that will read from Azure SQL and write into KQL database. Finally, we'll wrap up by building real-time dashboards on top of KQL database. Real-time dashboards are another exciting feature which allows you to reflect your data with the minimum frequency. A quick reminder before we proceed: if you are new to the channel, please take a moment and subscribe and like. Your support to the channel is invaluable for me. Thank you. Let's get started. So let's talk about real-time intelligence service. This service used to be around from the beginning of Microsoft Fabric introduction. It used to be called real-time analytics. In the last few weeks, Microsoft has rebranded it as real-time intelligence service. This service allows you to build low latency ingestion and transformation pipelines, as well as allows new real-time consumption dashboards, reports, and alerting mechanism. So it is event-driven as opposed to schedule-based pipelines that we talked about when we discussed data factory and data engineering. What I mean by that, you can create actions that will react to certain conditions in your data. And these actions can either be some notifications or some more complex actions that utilize flow pipelines. Here are the key technologies that are part of real-time intelligence. For data ingestion and transformations, we have event streams, which is a graphical pipelining tool allowing you to build quickly ingestion and transformation pipelines without any code. In terms of data storage and transformation, you can choose either KQL database, which is using Cousteau language. You can also store your data in Lakehouse and use Apache Spark to transform it. So if you are not familiar with these services, please take a look at a few related videos in my channel where I describe this storage and transformation methods in detail. So real-time intelligence offers real-time dashboards for data monitoring and reporting purposes. It also allows you to direct your data to data activator and build certain actions based on data conditions. So, as I described earlier, event streams is one of the core data ingestion transformations tools within real-time intelligence. It allows you to ingest from multiple sources, which I'll describe shortly. Optionally, you can also do certain transformations like aggregations, filtering, joining, and the results can go to different destinations. In terms of data sources, event streams can read data from some streaming services like Azure Event Hubs, Azure IoT Hubs, Amazon Kinesis data streams, Google Cloud pops up, as well as Confluent Cloud Kafka. So the last few services I mentioned here are relatively new. And you can also ingest from CDC-enabled databases like Azure SQL Database, Azure Cosmos Database, MySQL, and PostgreSQL. This functionality is also new. And then there are some other sources like blob storage events. So you can build your event streams to react to certain storage events like file arriving to your certain container or file deleted and so on and so forth. More recently, you can also ingest Fabric workspace events. This could be events on creating certain objects or deleting objects or any activities that can be done in Fabric. So this could be very helpful from Fabric administration perspective. So imagine that you build a pipeline which will collect all these necessary administration events into one place, where you can build dashboards and create dedicated action to certain conditions. Finally, event stream can also read from custom endpoint. So this could be your custom applications sending to event stream endpoint, or you can configure event streams input to act like Azure Event Hubs or Azure IoT Hubs. This is the idea that I have demonstrated in one of the event streams related videos. In terms of destinations, event streams can write to Lakehouse, KQL database, and Reflex. So Reflex is a data activator item. So let's talk about change data capture, which is a prerequisite for reading from database sources. Change data capture, or CDC in short, leverages transactions logs in related databases and allows you to read transaction history on applicable tables. So how can we enable change data capture? Enabling CDC is slightly different depending on what database you are applying it to. The steps I describe here applies to SQL. For Azure SQL Database, you have to first enable CDC on a database level and then on table level. How do we query transaction history? Once enabled for certain table, you can use the functions that you see on the screen to read from that table. So here you'll need to replace schema and the table name with the corresponding names. This function requires 3 arguments. From LSN and to LSN represent the range of transactions you want to read from, and they can be acquired using some built-in functions that I will describe shortly. And then you have to include row filter option. So row filter options can have 2 values, all or all update all. So what's the difference? So if you include all option, CDC will include only records that represent the latest state of your row in the database. So in case of update, you will only see change data, Whereas if you use all update all, you will get 2 records per each update. So the one record will represent the values before change, and then another record will represent the after state. In terms of insert and delete statements, both options will act the same way. So the data returned from CDC functions will include few extra metadata columns. Start LSN will include transaction log IDs for each row. Sequential val column will include a relative number of commands within the same transactions. So that could be useful for multi-command transactions. And operation column includes type of transaction. So you can see all the relevant values here. For example, if the row has been updated, then number 3 will represent its state before the change, while number 4 will reflect its post-change status. Apart from these metadata columns, you will also see the data itself after the change. Let me demonstrate this on the example Azure SQL database. For the purpose of this demo, I'm going to use sample AdventureWorks Azure SQL database, which you can easily provision when you create database. Keep in mind that it needs to be at least on premium price level, because that's the level allows change data capture. This database represents a sales schema, so you can see there is some sales related information here as well as some dimensions. I'll be mostly experimenting with customer table here. So the script you see on the screen will help us to complete necessary steps for connecting to the database from Fabric side, as well as enabling change data capture. I'll share this script in the description of this video, and let me walk you through different steps. My first command creates SQL user with password. I should mention that there are other authentication methods from Fabric to Azure SQL. So in this case, I have selected SQL authentication just to keep it simple. And then the next step adds this user to DB owner role. DB owner role is a highest database role. Normally in production environment, you want to assign a less powerful role for the purpose of replication. But keep in mind that that role needs to have access to underlying tables as well as CDC system views. The next command enables change data capture on a database level. And then I have a command that enables CDC for customer table. Once CDC is enabled, I have a command that imitates update transactions. In this case, I am changing modified date with the current date time, as well as I am assigning some test strings to suffix column. So I already run this command. Once you have applied transformations, then the command between lines 25 and 29 would allow you to see the output from CDC system views. To do that, I'm using multiple steps. So on step 26, I receive minimum transaction log ID for selected table. Notice that I am using schema name underscore table name. So that's the default format that CDC use to refer to the tables that have CDC enabled to. And then my next command gets maximum transaction number for all transactions. And finally, I use CDC get all changes function for this particular table. And then I provide minimum and the maximum transaction log IDs. So let me run this. CDC query results will have few system columns like start transaction ID, sequential value, as well as operation type. So this operation type will reflect type of transformation you have applied. So in my case, I used update statement, which corresponds to number 4. Next, we have update mask, which reflects columns that have been updated in this particular transformation. The remaining columns will reflect table's column state after the change have been made. All right, now that we have taken care of steps required from Azure SQL side, let's move on to Fabric side and continue streaming pipeline configurations there. So I am in Fabric's home page. Notice that I have selected the Real-Time Intelligence service. From here, I'm going to use Event Stream button under the New section. So I'll assign the name. I'll also select Enhanced Capabilities. This opens Event Stream's design page, and from here we have few steps to follow. So first of all, we need to add source. I'm going to expand Add Source button here, and we'll select External Sources. Here we have few choices, so I can select Azure Event Hubs and Azure IoT Hub, which I described in one of the event stream related videos. But I'm going to select Database CDC option, which is relatively new option. Notice that there is also Fabric Events option, which allows you to create streaming pipeline from events that you can get from Fabric, like object creation, deletion, things like that. So that could be useful for auditing purposes. So I will select Database CDC, and from here, as you can see, we have few options: Cosmos DB, Azure SQL DB, Postgres, MySQL. I'm going to select Azure SQL DB. And from here, I can create a new connection. So I'll hit New Connection button, and I'll provide server name, database name, and authentication type. So notice that we have basic authentication, which corresponds to SQL authentication. We can also select organizational account or service principal, which are more secure options. In my case, I will use basic account and provide username and the password. So I already created connection, so I'm just going to find my connection here. As a next step, I'll need to provide table I want to ingest from. Once I have table name, I can confirm my choice and hit Add button to complete source addition step. Once source added, then we can add transformations or destinations. To add destination, I'm going to use Edit button. Notice that I can do that from here as well. So we have two modes here, live option or edit mode. So I'm going to use edit mode, which opens a different design page. And here I can either add transformations events. So if I expand transformation events, I will see transformations like filtering, managing fields, aggregate, and group by, and so on and so forth. These are the transformations that I have described in event stream transformation video. For my purposes, though, I am going to select Add Destination button from here and select KQL database. Other options available are Lakehouse, Stream, and Reflex. So Reflex represents Data Activator service, which I also described in one of the previous videos. So once I selected my destination choice, I have to configure destination parameters. So let's take a look at destination configuration window. We have to select data ingestion mode, And the simplest mode is direct ingestion. The alternative option is event processing before ingestion, which may be necessary if you need to apply certain transformations before ingest. So I'm going to select direct ingestion. I will name my destination. So let's say KQL. We'll select my workspace, KQL database, and will confirm my configuration. Notice that I don't have a link between these two components, so I'm going to draw a line between these two. Okay, so once I have added my destination, I can publish my pipeline. So this will take a few minutes. All right, my pipeline configuration has been published. However, you can see a warning here. That's because my destination configuration is not complete yet. So remember that we have supplied database name, but we did not select table. So that's what I'm gonna do next using configure button. And here I can either create new table using this button, but I already have created this table, so I'm going to select customer row table and will name my connection. So that name needs to be unique. Then I will confirm my selection. Fabric did not discover any events in the pipeline yet. That's because I have run this pipeline earlier. So the event stream has ingested some events and it doesn't see new events. Let me go back to SQL Management Studio and run this update statement again. And if I go back, then I'll hit retry button to see if we have got new events. Yes, so we have new events. And I'll confirm my configuration. Then we'll close the window. Finalizing configuration usually takes few minutes. As soon as the configuration is complete, you will see your source and destination as a green. So my stream is up and running. So I can take a look at the data sample by selecting the middle component. So I have data preview and the data insight tabs here. So let me refresh this data preview page. So let's take a look at the data structure. My first column is a schema column, which includes structure information from table. The payload is the main column that I am interested in. So let's expand it and take a look. Here we get few nodes within the JSON. Before element shows data's state before change. And if I scroll to the right, then I have after node, which includes my row's state after the transformation has been applied. Besides payload, we have also event process UTC time, which could be useful in processing and parsing your output. We have partition ID and event enqueued UTC time, which reflects event ingestion time. We can also examine data insights tab, which will contain statistics about your data volume. So you can have number of input messages, output messages, as well as number of bytes. All right, now that I've completed event stream configuration, let's navigate to KQL database where we have ingested data to. I have created KQL query set, which I will be sharing with you in the video description as well. So let me zoom in. So the first command in my query set just takes a look at the first 100 rows. So let's run it. So as you can see, the structure is similar to what we have seen in event stream. So we have schema and the payload columns. So my next command has multiple transformation. At line 5, I extract after part of payload column using parse JSON and assign it to post update JSON field. Next, I convert TSMS field on the payload column to date time format, and I am doing that because the timestamp that's included in my events is in epoch format, which represents milliseconds from certain time point. So to convert it to normal date time, I am using two functions here. So I convert to begin, then I use Unix milliseconds to date time function to convert it to normal date time. So if I run the first two rows of this command, this is what we get. And then as a next transformation, I'm gonna use evaluate in combination to back unpack function to flatten these fields. So in other words, to extract all these field names into separate columns. So I'm gonna run these three commands. Now you can see each field in a separate column. So my next command converts modified date from epoch to date time format as well. And I am using similar techniques that I already described. Let me run this command end to end. So if I scroll to the right, modified date is in good shape. So one thing to notice here is that my output from this transformation contains multiple versions of the same row. So for example, if I take a look at customer ID 3118, I can see at least two versions. And that's because CDC produces new version every time I apply transformation. So that means that we'll need to apply deduplication transformation so that we get only latest version. To do that, I use argmax built-in function from KQL. This function requires column list by which you want to deduplicate. So in this case, I'm using timestamp column, which will get me most recent version of the row from my event stream. So if I run this, now I have each row presented only once in my output. All right, by this time, I have applied all the transformations and my data looks good. And I can build reports or dashboard based on the output of this data. However, I'm gonna go one step further and create materialized views, which will simplify the way I refer to these transformations. And its advantage is that you can treat it as a table. So in this example, I create materialized view named customer MV, and I have included all the transformations that we have discussed earlier. One thing to notice is that materialized views are normally created empty and populated with data that arrives after to dependent tables. And if you want materialized view to be populated immediately, you can use backfill true parameters, which I used here. So I already run this command and I have my materialized view. So let me run this simple command, and that produces my transformed data. All right, I have ingested data in the KQL database and I have processed and transformed it. The next logical step is to visualize this data. And to do that, I have few options from KQL side. I can use pin to dashboard or build Power BI report options, which will allow me to create reports and dashboard. These are options that I described in one of my previous videos. This time I'm gonna use real-time dashboard option, which is another new addition added to Fabric. So to do that, I'm gonna use create button. And from here, I will scroll down and find real-time dashboard option. I'll name my dashboard. Then I can add tiles here. So I'm going to add my first tile, select data source. As you can see, at this point, only KQL databases are available as a source. I'm going to select my KQL database and confirm. Then I can provide the command. So my query will include materialize view that I created earlier. So let me run this and I'll confirm my selection. So my first transformation is going to be very simple. Next, I'm gonna put the title. So I'll say detailed customer list. Optional, I can change visualization type. So as you can see from here, I have different types of visualization. However, in my case, I'll keep table option here. So this is going to be detailed list. I can keep adding other tiles to my dashboard. However, in my case, my data does not have too many numeric columns. So I'll keep it simple. I'll just save my configuration. And optionally, I can also change refresh rate. So if I expand this, you will see many different options, including 15 minutes frequency. You can also set custom range where you can specify date time from which to refresh your reports. So that concludes today's discussion. To recap, you can use real-time intelligence service, which includes everything from ingesting to storing and transforming and finally consuming your data. I hope this was helpful. Thanks for watching and I'll see you in future videos.